Hi everyone, welcome to the drill press demonstration. I'm going to be introducing you to this tool to my right, which is a drill press, of which in the lab there are two. There's a green one there, the General, and we've got the King Industrial here. I'm going to be demonstrating on this one because I think it will pick up a bit better for the camera. It's also our latest edition. But I would encourage you to try both in the lab. They're very similar. They have all the same bells and whistles, so make sure that you're ambidextrous and understand how to use both tools. First and foremost, safety. Always, always, always make sure you're wearing the appropriate PPE. No jewelry, hair is tied back. Safety glasses are a must. And if you're wearing a business tie, tuck it into that colored shirt that you wore to the lab for whatever reason. So first of all, we'll go through the components of the tool. We've got an on-off switch, and green is on. Starts it up. Red is off. I've got a feed lever, so using this guy, I can control the drop down of my cutting tool into the material. So this is a feed lever. This is referred to as the quill. The quill is cutting straight down onto my table. So that's at a 90 degree to my table. And this is referred to as the chuck. And the chuck is actually the grip that is grabbing whatever my bit or cutting tool may be, whether it's a countersink or a twist bit or an auger. So has an adjustable size, and it can grab half an inch larger, 3/4 of an inch, and I can tighten that tool using the key, which looks like this. Please do not put this in your pocket and walk away from it. We need it. It's what allows us to change out our bits and operate the tool safely and effectively. So just make sure that whenever you're using this, you don't walk away with this guy. So this is a key that allows us to tighten our bit in. I'll try to give you, I'll bring the camera in for a closer view of what that looks like. So again, feed lever, on-off switch. Here we've got our table adjustment. So this allows us to lift our table, lower our table. If we're using a larger bit or we're working on a larger piece of material, we can accommodate, goes down quite far. And we can tighten that in the back so that it's not swinging around on us too much. This is our pulley cover. If I open that up, you're gonna see a series of belts and a series of pulleys. On the back here, there's a motor. This allows us to operate variable speed. So this is a variable speed drill press. And depending on which step the belt is on the pulley, it can either go slower or faster. So we can work on a number of different materials. We can work with a number of different size tool bits. So as a general rule, the smaller the cutter and the softer the material that you're drilling into, the faster you can run the cut. The opposite of that is also true. So if you're working with a large cutter tool and a very dense or hard material, you're going to want to slow down that cut. So if you're cutting into something like metal or glass, you're going to want to slow down the number of RPMs that are happening for your quill. And if you're working on something soft like poplar and you're using a small pilot hole, you can cut faster. Okay? In the shop, you don't necessarily have to worry about that. We sort of leave it as is because we're working on very similar materials. There's not a huge amount of variety that's coming in, so don't worry too much about that. If you notice there's a huge amount of burning, try changing out the bit because it's likely a reflection that your bits are quite dull. So leave that pulley cover over. We just don't want any of those belts or pulley systems exposed when the tool is on. Again, on-off switch, motor. This is a fairly substantial drill press. It's large, it's going all the way to the ground. These things come in all different sizes. They can be smaller on your bench top. They can be large and industrial size like this guy. The size of the tool is actually determined by the swing. So when I say the swing, I mean the distance from the center of the quill to the outside portion of this column here. So times 2. We're talking about a piece of material that we could rotate here. So this one is actually about 17 inches. So this is a 17-inch drill press. That one I believe is a 16-inch drill press just because that distance is slightly smaller. So just know that a variable speed drill press, the size of it is determined by the size of the material that you can operate on the tool. Some things that are important, you'll notice that we've got an auxiliary table fastened onto our table. There's lots of holes in it. If you're trying to drill something on a show face, make sure that you put a waste material underneath it. So whatever it might be, where there isn't already a series of holes drilled, you're going to want to drill into your piece with something underneath it. So when you break through, or the bit breaks through the other side, you have something to support those fibers. Otherwise, you're going to get tear out, which can be problematic on your final project. It's hard to remedy once you've already sort of damaged that material. So using a waster is really helpful to maintain the surface prep of your material. If you're using something large, this is called a Forstner bit, circular, and it leaves a flat bottom, but it's a fairly large, substantial drill bit. If you're using this, it's a good idea always to clamp your piece to your table so that it doesn't, do something that you weren't prepared for it to do. So just as a safety precaution, if you're working with large materials, cutting large bits, make sure that you're please clamping down your material. So why do we use a drill press? The drill press is essentially technology developed as an extension of the human arm holding a power drill, a portable power drill. But I don't know about you guys, if I need to drill 10 holes that are all 90 degrees and at a certain depth, my trusty hand using a power drill is likely not to get the best result. So the drill press allows us to precisely drill a hole at 90 degrees if that's what we need it to be, but then also we can accurately replicate that same cut over and over again. So this is why we use a drill press, because it eliminates human error, or helps to eliminate human error. It doesn't entirely eliminate human error. But not only that, I mentioned earlier, we've got the variable speeds. It allows us to safely operate using larger cutters, allows us the opportunity to clamp things down. We can use a fence if we need to cut holes in a very straight line. It's got a depth stop, so if we need to cut holes at the same depth over and over and over again, it has all these extensions that we ourselves can't do. So it just makes cutting efficient, effective, which is why power tools exist in the first place, right? I mentioned we've got the variable speeds. If I need to cut something really soft, or if I need to cut something really hard, I can have those set adjustments instead of just trusting me pulling a trigger on a drill. In the shop, it can go up to 4,500 RPM. We don't ever need it set to that. In the shop, we're working at much slower paces because we're working with softer materials. We're working with similar cuts, as I mentioned, so around 1,500 RPM, I believe, 700 to 1,500 RPM. We're working at a bit more of a relaxed pace. We can use this tool to help us repeat the same action over and over again safely and quickly, which is why this is a great tool to get to know. If you are looking at the test, you'll see there's some signage here mentioning different drill bits, and we also have the drill press cabinet. Get to know some of the bits that are in those cabinets and their purpose, why we use them, why we don't use them, when one is appropriate over the other. Just get familiar with the drill bits, because that is going to be on the written portion of the test that you're going to see. And there isn't necessarily a drill press exercise that comes in collaboration with this demonstration and the test, but you will be using this tool frequently throughout your time here in the lab, and then furthermore throughout your career down the road. So make sure that you understand the ins and outs of the drill press. So I'm going to bring you in a bit closer now and just sort of show you how to change out bits, how to drill into material, and how to use some of the additional functions. Okay, so I've brought you in a little bit closer, and I'm just going to show you how I would install a drill bit. Right now I've just got a clearance drill bit, twist bit, but again, like I said, this chuck, you can adjust it. So if I am turning it to the right, it's actually getting larger and it can accept a larger shank like this guy. But if I close it up, it can also grip a smaller shank of this drill bit. So in order to do it, I'm just going to nest it in there and hand turn it hand tight. And what I want to make sure is that the bit is resting in the center of all of these three grips. If it isn't, when you go to tighten it, it's going to spin all out of sorts. And if that happens, just turn the tool off, wait for it to come to a full stop, and adjust so that when you do turn it on, it's spinning on center. So now that I've got it hand tight, I'm going to use the key. Righty tighty, lefty loosey, just a little bit. You don't have to reef on it too much. And once I've got that where I want it, make sure you put the key back. And then I turn it on, and it should be spinning on center instead of spinning around, spinning out like I mentioned. Let's suppose that I need to make a series of holes that are all going to be in a line. So I'll just draw a line. Okay, on a line, and I need them to all be about 1 inch from one another. So let's just do this quick. 2, 3, 4, 5, 6. So I've got a line with a series of holes. It is very unlikely, for me at least, but it's very unlikely that I could go ahead and just freehand this and expect all of those holes to be drilled in the spot that I wanted them to be drilled into. So I've got my waster board here so that I don't get a ton of tear out. What I can use is I can attach a fence. So I've got a straight milled up piece of wood that I can just clamp onto my table, and that's going to help me drill those holes where I want them. In addition to the 1-inch straight line holes, let's suppose that I need them to all be the same depth. So this is the depth that I require them to be set at. So the first thing I'm going to do is I'm actually going to set my depth. Pull in the feed lever, line it up about to where I need it. So let's say that my depth, and I can use the depth stop. By spinning these down, slowly but surely, there we go. It stops me from being able to push down harder than that, and also will allow me to get that same depth with every cut. So using these, I can adjust it, make them shallower, I can raise them up and make it deeper, but I'm just going to stick to where I've drawn my line. So I've got my depth stop set, so I can do that same thing over and over and over again. Next, I'm going to set my fence. So I'm going to attach one side just with a clamp. Make sure that you don't have the clamp handle up because it's going to interrupt your feed lever. So clamp handle down onto my auxiliary fence there. That's attached to my table mount. Let's say right about there. So that one doesn't have to be so accurate, but the next clamp that I attach has to be very accurate. So right about there, I'm going to go to the other side. And all I'm going to do is line up my first hole. Okay, I'm going to come back up, turn the tool on, holding the piece. I can use my left or right hand with this tool, whatever you're more comfortable with. Just make sure you're not doing something too silly. I'm going to turn it on. I'm going to make my first cut, come back up, shift it down the fence, and go ahead for my second cut. If you are cutting deep material, if you're making a lot of cut, you're going to want to do what's called a plunge cut. So you're going to cut into the material and then relieve some of that waste so that it can follow along the fluting and escape. If I just try to cut through a really thick piece, it's going to burn, it's going to dull my tool really quickly, and it won't be effective. So if you're cutting through a lot of material, make sure you plunge in a little bit, back off, plunge in a little bit deeper, back off. Okay? So I'm just going to go ahead, line up my first cut. Trying to keep my hands out of the camera there. Go ahead, turn it on. And because I have that depth stop, it's going to stop exactly where I want it to. So I'm going to back out of my cut, slide it down. Right there is where I want to be. I can back out of that cut, slide it down. Turn it off. Here we go. So, series of holes, straight line, 1 inch apart and the same depth deep. You'll notice that I didn't clamp down my piece. I'm working with a fairly small bit. Careful not to touch where it's hot because it'll burn you, so don't go ahead and change that out because it will be hot from all the friction. So you'll notice that I didn't clamp down my piece while I was working with it because it's a fairly small bit and a fairly small piece, and I'm using a fence. I felt very comfortable just freehanding that. Again, if you're working with a larger bit and a larger piece, I would encourage you definitely to clamp it down to the table. And like I mentioned, when you go to take off this bit after it's turned off, so returning it to the way that you found it, which is always a good shop practice. So loosening the key. When you grab the bit, make sure that you've not just done a series of many cuts because it will be hot and you can burn yourself. So thank you very much. If you have any questions, please feel free to let us know. Welcome to the drill press.